Welcome to our presentation on business objects. We'll explore how to transform visionary ideas into practical code. Key topics include the role of business objects in N-tier applications, design principles, and class interactions. Our goal is to provide clarity in navigating the complexities of distributed architectures. We intend to answer the following questions. Where are business objects in an N-tier application? How do business objects make reuse easier? How do you design business objects? How many classes are needed to create one business object? How do classes interact to create a business object? In an N-tier application, business objects are positioned between the user interface and database services. They facilitate communication, ensuring that the UI interacts with the business logic without directly accessing the database. This layered approach enhances modularity and maintainability. Design layers differ from physical deployment layers. They enable distributed architectures by allowing applications to scale from single users to enterprise-wide systems. While adding complexity, they offer flexibility in deployment, crucial for modern software solutions. Business objects enhance reuse by adhering to design principles like coupling and cohesion. Properly designed objects minimize interdependencies, making them easier to maintain and adapt. This slide explores the challenges and benefits of implementing these principles. Coupling is unavoidable because if two programs are to accomplish a task together, there must be a minimum degree of coupling. The objective is to minimize the amount of coupling in an application. Cohesion is a measure of the single-mindedness of a program. We want to maximize the degree of cohesion. Design forms with low coupling and high cohesion simplify maintenance. By isolating problems, they make reuse more efficient. This slide illustrates how object-oriented programming can reduce coupling and enhance cohesion. Using a purchase order example, we can see an example of what is incorrect design as opposed to a correct design for measuring both coupling and cohesiveness. Mapping to a reusable architecture involves separating design layers to minimize coupling. This slide discusses how to achieve this by isolating data storage knowledge from the UI, enhancing the potential for reuse and adaptability in software design. For example, removing knowledge of physical data storage, the name of the database, table, columns, etc., from the UI and moving it to a single piece of code results in the business object's design exhibiting high cohesion and low coupling. Designing business objects requires careful consideration of layer responsibilities. This slide outlines rules for creating effective business objects, emphasizing simplicity, UI agnosticism, and the importance of exposing essential services through methods and properties. Think of the business object as a service provider to the UI. It is the responsibility of the UI to make use of these services, creating the interaction with the user. A robust UI might take advantage of a business objects event to enable the update button on the form. Visible Developer applies design principles to create distinct layers: user interface, logical business object, physical business object, and database services. Each layer has specific responsibilities, ensuring a cohesive and efficient application structure. Take notice of the role defined here for each one of the layers. Separating information and responsibilities among design layers is crucial. This slide details the roles of each layer in a Visible Developer application, focusing on maintaining cohesion and reducing coupling to enhance application performance and maintainability. It is important to distinguish responsibilities across the layers. You need to understand what each layer knows and what it doesn't know. Creating a business object involves multiple classes across different layers. This slide explains the complexity of business objects, highlighting the roles of various classes in the logical and physical layers and their collaboration to form a cohesive unit. Visible Developer generates 4 classes for each business object. 3 classes are contained in Layer 2, the logical business object, and 1 class is contained in Layer 3, the physical business object or persistence layer. Class interactions are key to forming a business object. This slide uses a database example to illustrate how classes in different layers work together, facilitated by Visible Developer, to create a functional and efficient business object. Visible Developer offers developers several code generation options, including the ability to generate three styles of forms: list, detail, and lookup. Generated components include class modules, standard modules, and forms with controls and code. The user interface layer is the first point of interaction. List forms and their associated search forms display business object property values in a tree view control. After a particular customer or purchase order is selected, it can be deleted or changed using a detail form. After code generation, developers refine each layer as a project. This slide highlights the components of the UI layer, focusing on how forms and controls interact with business objects. The logical business object layer contains class modules for business logic. Visible Developer generates classes that manage data and operations, ensuring that business rules are enforced and data is processed efficiently within the application. Visible Developer creates three classes for each business object in Layer 2 of the application: Business Object, Business Object List, and Business Object Batch. The physical business object layer handles database interactions. This slide explains how classes in this layer correspond to logical classes, focusing on data persistence and the execution of business rules to maintain data integrity. The classes generated by Visible Developer for Layer 3 correspond to classes in Layer 2, and the methods for related classes are nearly identical. The purchase order list form demonstrates how UI components interact with logical objects to perform tasks. This slide emphasizes the importance of moving knowledge to appropriate layers to strengthen cohesion and reduce application coupling. A UI designer uses a list object, like purchase order list, as a convenient utility object to perform searches and make the results easily accessible. Notice the UI's knowledge of the business object is limited to the names of properties. The purchase order list object in Layer 2 provides services to the UI without directly accessing persistent data. This slide illustrates how it maintains purchase order data, enabling efficient interaction with the UI and reducing unnecessary complexity. Objects in Layer 2, or logical objects, do not directly access persistent data. As shown in this code sample, the purchase/order list object creates a purchase order persist object and uses its search method to obtain purchase orders matching the criteria. Layer 3's purchase order persist object manages database operations. This slide details how it translates between logical properties and physical data structures, ensuring seamless data retrieval and manipulation across application layers. The Layer 3 object, purchase order persist, understands how to translate between the logical view of the object's properties and the underlying physical view consisting of database tables and columns. This layer is responsible for making the database connection, not shown in the sample code, converting property names to column names, also not shown, and creating record sets. Creating and loading a purchase order business object involves reading current property values from the database. This slide explains the process, highlighting the interaction between layers to ensure data consistency and integrity. Notice, in the example, the detail form has a text box and text number that displays the value of the purchase order's number property. Whenever the business user tabs through the text number text box, the UI sets the business object's corresponding property value to the control's value. The purchase order detail form's lost focus event demonstrates the UI's role in reporting values to business objects. This slide emphasizes the separation of responsibilities, ensuring that the UI does not interpret data, but responds to business object events. The UI only reports values to the business object. It does not attempt to interpret them. If a business object discovers an error, it raises an event, and it is the UI's job to respond to the event appropriately. Notice how the final lines of code in the sample seem contradictory at first glance. Why does the UI obtain the number property from my purchase order when it just sent the value to the object in the previous statement? The reason is the strict line of responsibility between each of the layers. The property let method in the purchase order object encapsulates data validation logic. This slide shows how responsibilities are shifted from the UI to the business object, promoting reuse and maintaining a clean separation of concerns. The final step in this example shows code from the property let sub in the purchase order business object. The code should look familiar to programmers. It is similar to statements previously contained in a form. The responsibilities, and hence the code, for data validation are removed from the UI and placed with the business object. Encapsulating logic within the business object makes it available for reuse by any UIs, forms, web browsers, or Excel spreadsheets that use the business object. At this point, we have reached the end of our introductory slides on business objects. If you are interested in pursuing this further or taking Visible Developer for a test drive, then please contact Visible Systems Corporation by emailing contact@visiblesystemscorp.com.